and Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Hajar Wahida binti Jamaludin with metric number 146032. I am currently 4-year student majoring in pure physics and minoring in astronomy. Aurora. What will pop out in your mind when I say aurora? I bet every one of you guys will imagine a beautiful dancing wave of green light in the Arctic sky, right? Aurora is a very magical phenomenon that ever happened on our planet. But did you guys ever wonder how it happened? To find out about this, you guys have to stay tuned until the end of this video, because in this video, I will talk about space weather and how it related to aurora. A brief introduction about space weather. Space weather basically is any activity that happens on the sun's surface. Even though the sun is really far away from us, it's about 93 million miles or around 150 million kilometers from the Earth. However, it still can affect Earth and the rest of solar system. At its worst, it can even damage satellites and cause electrical blackouts on Earth. That was so serious. As you can see in this infographic, there are many types of space weather, which are firstly is sunspot. Sunspot is area that appear darker on the surface of the sun. This is because they are cooler than other part of the sun. Why they are cooler? It is due to the magnetic field at that particular area is very strong that they keep some of the heat within the sun from reaching the surface of the sun. That's why it looks darkest on that spot. Secondly, solar flares. Solar flares is a sudden explosion of energy that caused by reconnection of magnetic field line near the sunspot. These solar flares release immense amount of energy at the speed of light. Therefore, it only took 8 minutes from them to travel from the sun to the earth. Amazingly fast. Meanwhile, coronal mass ejection or CME is a huge bubble of radiation and particles that released by the sun. They are formed similarly to the solar flares before, but they travel at slower pace. These CME have their own magnetic field and can slam into and interact with Earth's magnetic field. Next is solar wind. The solar wind is a constant outflow of photon and electron from the sun. They are always present and always buffeting our Earth's magnetic field. After that is solar radiation storm. Solar radiation storm occur when the sun emits a huge burst of energy in form of solar flares and coronal mass ejection. And last but not least is geomagnetic storm. Geomagnetic storm is a temporary disturbance on Earth's magnetic field that typically caused by the enhancement of solar wind. That's pretty much introduction about space weather. Isn't it fascinating to know how all this space weather stuff could create aurora on Earth? Now for the best part, I'm presenting to you the tale of aurora. Everything was started from the sun. The sun acts as a power plant that could release energy, where, deep inside the core of the sun, there is a nuclear reaction happening. At temperature over 40 million degrees and pressure is very high, the hydrogen atom inside the sun are squeezed together into another element, which is helium. This process releases energy, and that's where the energy comes from. In some places, strong magnetic field push their way up through the surface of the sun and appear as sunspots. And then, when the sun emits huge bursts of energy in the form of solar flares, the solar flares will trigger solar storm to occur. This phenomenon will send a stream of electrical charges and magnetic fields toward the Earth. After 18 hours, the solar storm reached Earth. When the solar storm reaches our planet, the protective magnetic field around the Earth will act as an invisible sheet and deflect all the particles and energy that come from the storm. But some of them can escape and travel down the magnetic field line at North and South Pole into Earth's atmosphere. There, the particles interact with gases in our atmosphere, resulting in a beautiful display of light in the sky.